do an example with mid-range k's. Mid-range k's are k's between 0.01 and 100. I think it's misspelled, or there's a misprint here and it says 10, but it should be 100. Anything above 100 is large. Anything below 0.01 is small. All right. Now, because with mid-range Ks, every time that we've been able to work with these types of problems, we've been able to simplify. But there is no simplification on mid-range Ks. We want x to be small, so we're going to have to use the quadratic equation. I don't really know why it says we hope. I hope that you can use it. All right. So in this case, we have our mole concentrations up here, and we have to calculate our molarity. It is in a 2-liter container, so that means that molarity is moles divided by liters. So each of these amounts are cut in half to get our molarity. So for this one, it is 0.9000 to keep our sig figs. And again, that's moles divided by liters. I just divided by 2. This one's 0.8000 molar. So we get to put those there. And this one is going to be 1.300 molar for HI. Okay. Now, for this type of problem, we need to we need to write our K expression, our equilibrium expression. It's the same one as we saw before. Times I2, products over reactants. All right. In this particular reaction, we need to figure out which way the reaction is going to shift. So we're actually going to figure out Q first, and that's going to tell us which way the reaction's going to go when we first start, if we put these concentrations that the problem says in there. So Q is done the exact same way as K. It's just at non-equilibrium conditions. All right, if we plug in these amounts that I have here in blue into this to get my Q, I get 1.300 squared over 0.9 times 0.8000. All right, so it gives me a Q of 2.3. Now, if we compare K and Q, and if you write it this way, it tells you which way it's going to shift. K is 38.6, and that's because they tell me this here. Q is 2.3, and so K is bigger than Q. That means the reaction is going to shift this way. So the change is going to happen. It's going to make more product, and that's going to help me figure out where to put X. And we're going to do this a little different. Still involving X box. All right, so I'm going to go ahead and get rid of this here so I don't confuse you guys. And this is still my equilibrium expression. Okay. So I have H2 plus I2, and that's going to give me HI, 2 of them. All right. 0.9, ICE. So 0.9000, 0.8000, and this one is 1.300. Now, I'm going to be making more product, so the change is going to happen here. This is the difference with mid-range Ks and those large and small Ks. We're going to actually have our X in the change part. HI is going to change. It is going to increase, and we know that because the reaction is shifting to produce more products. So we're going to get more products. All right, so that's going to be my plus X. Now what I'm going to do is translate that, my change, to H2 and I2. So if I cross over, I've got to make the sign opposite. And I'm also going from 2 to 1. All right, if I go to I2. And so this is going to be, it's actually going to be half, and it's going to be negative 0.5x. The same thing is going to be true for H2 because it is also has a coefficient of 1. So negative 0.5x. Now I get my equilibrium, and you're just going to add your initial and your change together to get your equilibrium. And so that's 0.9000 minus 0.5x. For I2, it's going to be 0.8000 minus 0.5x. And for HI, it is going to be 1.300 plus x. I'm going to take these equilibrium concentrations, and that is what I'm going to plug in to my equilibrium expression. All right. So let's try and do that maybe over here. Didn't leave myself a whole lot of room. All right. HI is 1.300 plus x squared over 0.900 minus 0.5x. That's my H2. And then I2 is going to be 0.8000 minus 0.5x. And that is going to equal K, which is 38.6. Now I have an equation with some nice algebra that I can get the quadratic equation. All right, I'm going to run through that really quick. I'm not going to bog you down because that's why you took math. Okay, so through 38.6 equals 1300 plus x, and that is squared, over 0.9000 minus 0.5x times 0.8000 minus 0.5x. And again, don't get bogged down in this. You can do it. It is just rearranging, combining like terms, which I haven't done in a while. All right, I ended up with combining like terms and rearranging this equation to get 8.65x squared minus 35.41x plus 26.1 equals 0. This is an equation I can plug into the quadratic. The quadratic gives you two answers. Only one of those answers will be correct. When I plug this into the quadratic, I got 0.9643 or 3.129. Now, to determine whether whether x is ridiculous or not, you can plug it back into one of these concentrations. If I look at this one, 0.9 minus 0.5 times x, 0.5 times 3 is going to give me 1.5. And I cannot subtract 1.5 from 0.9 and get a whole number. I would have a negative concentration. So that means this is the ridiculous answer. This is one that will actually work, so that is going to be my x. And then I can calculate, I can plug x in to each of these concentrations up here, here for HI, here for H2, here for I2. And I can find those concentrations there at the end. Now, quadratic equation, something like this, is not something you'll get on the multiple choice. It is something that you could get on the free response. But you can do the quadratic, and the AP exam will expect you to do the quadratic. But they might do some tricks. Now, this is the end of this problem. I'm just going to show you one of the tricks that I've seen happen. If your H2 and I2 had the exact same concentration, so let's say they were both 0.9 instead of one of them being 0.8. If you look at this now, you have this squared, and then basically 0.9 minus 0.5x squared, because they're multiplied by each other by the same thing there. So both things are squared on top and on bottom, so you can take the square root of both sides, and that way you can get around doing the quadratic, if that happens to be the case. The way this original problem the one I just worked, was written, that is not the case, and you had to do the quadratic. But again, it's something that you are able to do.